Hello, colleagues. Welcome back to our transportation problem series, where we've been looking at transportation problems and the different methods that are concerned with transportation problems. Okay, and we know that transportation problems are a branch of the linear programming models that helps us minimize the shipping cost of particular goods from their origin or factories to the destinations. So we have different methods, and in the previous videos we looked at the least cost method and the northwest corner method. Today we are looking at the VAM, which are abbreviations of Vogel's approximation method. And we are saying that we have steps towards solving these particular problems or using this method. The first step involves identifying the two lowest costs in each row and column of the given cost matrix, and then write the absolute row and column difference. These differences are called penalties. So when you identify your two lowest costs in the matrix, the box that you are going to be given, you subtract the smaller from the bigger, and that particular difference you're going to get after you subtract, that one is called your penalty. Okay, the second stage is identify the row or the column with the maximum penalty and assign the corresponding cells minimum supply or demand. If two or more columns or rows have the same maximum penalty, then we can choose one among them as per our convenience. Okay, that was a standard rule a while ago, but now we are going to realize that we'll use a different method when we have two maximum digits in the same row. We're going to use a particular strategy to work out the problem. The third stage is if the assignment in the previous satisfies the supply at the origin, delete the corresponding row. If it satisfies the demand at the destination, delete the corresponding column. Okay. The last one is stop the procedure if supply at the origin or at each supply is equal to 0. Every supply is exhausted and demand at each destination is 0. That is, every demand is satisfying. If not, repeat the above steps. That is from step 1 to step 3. Okay, so these things that I'm saying, I'm reading right now, don't make sense. Okay, you appreciate more when they will make more sense when actually we solve the problem. Here is a problem we have. Okay, here is a problem we have. We have factory. Let me just okay. We have factory 1, factory 2, factory 3. And factory 1 is producing 50, factory 2 is producing 60, factory 3 is producing 25. And D, we have destination 1, destination 2, destination 3, destination 4. Destination 1 wants a demand of 60. Destination 2 wants 40, destination 3 wants 20, and destination 4 wants 15. Now, the first stage, whenever you are trying to solve this, first step is check whether the supply side is equal to the demand side. Okay, you have the demand consisting of 60, 40, 20, and 15. You have the supply consisting of 50, 20, 60, and 25. Okay, so you add these ones and add these ones also. If they give you the same figure, then it's a balanced problem. If they don't give you the same figure, it's not a balanced problem, and you need to introduce what we call the dummy column. So in this particular problem here, we're going to limit ourselves to a balanced problem. We are going to realize that when you add the demand and the supply, you are going to have the same digit. Okay, let's add now. Let's see what we are going to get. We have 135. So 60 plus 40 is 100, and 100 plus 20 is 120. 120 plus 15, that is 135. That's the same arrangement here. 50 plus 60, that's 110. 110 plus 25, that gives you 135. So on both sides, you have the same number. So please, the first step, add those and find the same answer. If you don't, then we will see in the next video what we are going to do. But for now, this is a balance. It's called a balanced problem. And since it's a balanced problem, we can proceed. Okay, you draw a line like that. Okay, then as the first stage says, identify your two smallest digits. You have box 1, box 2, box 3, box 4. Okay, and this is your row. You will start with rows. Okay, identify your two smallest. You realize that amongst the smallest, you have 2 is being the smallest, the second smallest is 3. Then subtract the smaller from the bigger. So 3 minus 2 gives you 1, right? In the same row here, you put 1. That's difference. This is called penalty. Penalty. Okay, you write it like that. You go to the second row. You have 2 and 3 as the smallest. So the difference there is 1. The third row, you have 2 and 4, right? The smallest is 2. Okay, since all the rows are done, you will start with the columns now. Okay, under D1, which is column 1, right? You have the smallest being 2 and the second smallest being 3. The difference there is 1. You put it on the downside, 1 there. D2, you have 2 being the smallest, the second smallest is 5. And you have 2 5s there, so you can pick any of the two. There's no difference. Okay, let's pick this one. The difference is 3, right? You on D3, the smallest is 2, the second smallest is 4. The difference there is 2. D4, you have 3 and 5. The difference is 2, right? Okay, you see what we have done there. We have found the differences for the rows first, then we have found for the columns on the second. Then we repeat the process again. But before we repeat the process, this is what we're going to do. Amongst these penalties that we have jotted down, calculated, we have 1 and 2. We have 1, 3, 2 and 2. Amongst these, starting from the row, we pick the biggest number, the biggest digit. Amongst these, the biggest digit is 3. So 3 lies in this particular column. So in this particular column that has these values, you identify the smallest in this column. And the smallest in this column is 2, which is in the first box, right? Okay, you've identified that box. Then you ask yourself, this box is dealing with this particular supplier and is dealing with this particular demand or destination, D2. So it's F1, D2. But factory 2, how much is factory 2 supplying or producing? Factory 1. This is factory 1, right? Factory 1 is producing 50. But D2, how much does D2 want? Well, he only wants 40. Meaning F1 can give D2 the 40 that D2 needs. So you give 40. When you give 40, meaning D2 will no longer need anything, so you put a 0 there, right? Since they don't need anything. But when you give 40 from this 50, from this supply you have given D2 40. How many will F1 remain with? Factory 1. You remain with 10, isn't it? Okay, you have allocated there. You start this process all over again until you have zeros on this side and zeros on this side. So let's start over the process again. Okay, so we draw another line like that. Okay, we start the process again. In the first, so where we have a 0, we can cancel out everything here since we have a 0. Okay, we start with the rows again. The first row, what are the differences? You have what is the smallest digit? We have 3. 2 is cancelled since you have already allocated there. The next smallest is 6. What is the difference? The difference is 3. The second row, you have 2 as the smallest. The second smallest is 3. The difference is 1 there. 3 minus 2 is 1. The third column, you have 2 there and you have a 4 there. The difference is 2, isn't it? We go to the columns. So the column D1, you have 3. You have 2 as the smallest and 3 as the second smallest. The difference is 1. This D2 has been cancelled since there is a 0 there. We are done with this one, so we skip it. So we can just put a dash there. D3, you have 2 and 4, so you have a 2 difference there. D4, you have 3 and a 5, you have a difference of 2. Okay. From here, you ask yourselves, amongst the penalties that you have written, which one is the biggest? We have 1, 2, 2, 2, 2, 3. So 3 is the biggest, right? So you work with this particular row. Okay, and in this row, okay, let me just clear the smallest in this row. Since 2 is already cancelled there, the next smallest will be 3, this one. So you allocate here. So what are the factors involved? You have F1 factorial 1 and you have D1. D1 needs 60, factorial 1 is only remaining with 10. So let's give all the 10 that is remaining. So you give, so factorial 1 will have 0 now. While destination 1 will still need 50. Since you've given them 10, they'll still need 50. Excuse me. So let's repeat the process again. Okay, so we write another box like that. Some lines like that. We start asking ourselves, so which one have we cancelled? Which one is a 0 now? So this whole thing is a 0. So we cancel, we are not dealing with row. So we are done with row 1. So when we are starting again to look at the smallest, we are starting from row 2. So row 2, we have the smallest as 2 and the next smallest as 3. The difference is 1. So here there's a dash since we are done with that row. Row 3, we have 2 as the smallest. The next smallest is 4. 2 is the next. Then we go to the demand. This demand, we have 2 as the smallest and 7 as the next smallest. Since 3 has already been allocated to, we are not using it. 3 is in the position where we have allocated 10 there. So 2 minus 7 is 5. So we have a 5 there. We go in the next row. Let me just clean up the board. Okay, so we skip this one. We go to D3. D3, the smallest is 2. The next smallest is 4. That the difference is 2. In the in the column 4, we have 3 and a 5 there. So the difference is 2. Again, we ask ourselves, which one is the biggest amongst this one? It's 5. So we are dealing with this particular column. Okay, we allocate. What are we allocating? D1 needs 50. Okay, we know first of all we identify which one is the smallest. The smallest is 2 in this particular column. So in the 2 we have factory 3 and D1. So factory 3 can supply 25. Demand 3 needs 50. So let's give the 25. We give 25. So here we'll remain with 0. We've given all the 25. But when we give 25, we'll still need another 25 since we needed 50. So now we will need 25. Okay, so we'll continue this particular problem and repeat the same thing in the next class.